Today we are going to discuss chapter 2, and the title is the organizing the data. So we are going to discuss the frequency distribution, histogram, and more. The first topic will be the frequency table. Okay. So now here is an example. It's a commuting distance for 60 workers. So we have 60 individuals. What variable? Distance. The commuting distance in miles. Just a second. We had two types of the variables. You remember the two types of the variables? Thank you. The qualitative and quantitative. The qualitative was the categorical variable, and the other one was the numerical. Only two types, right? Which one? Distance. Quantitative, yes, numerical. It is a numerical, right? And also, we had 4 levels of the measurement: nominal, ordinal, interval, ratio. Absolutely, the numerical variable is never ever nominal, right? So we have 3 choices. In order, yeah, the smaller value is a shorter one. The bigger value is a longer one, but I think the ordinal scale is not good enough, right? So let me have 2 choices: interval and ratio. Do you remember what was the difference between the interval level and the ratio level? True 0. The value 0 was the key. If the 0 is equal to none, what? Ratio. The other one is not none. For example, it's a temperature, latitude, longitude. It's not none, right? It's the interval. Look at this. Distance. 0 distance. 0 miles. Nothing. Then what? Ratio. So now, I can categorize the distance is numerical. Ratio level of the measurement. Does it make sense? Okay, good. So now we have 60 individuals, and let me make the frequency table. The frequency table is very easy. It is a table with the frequencies, right? So here's a table. Here is a frequency table for the variable with the 60 individuals, right? First of all, we have to understand what is the class limits. See, today we have a variable distance. It is numerical. When I make the frequency table, we have to categorize. We have to classify the numerical variable into some interval. That will be the class. Okay? So to determine the class limits, we have to know the size. What is the size? It's between 1 and 8. 7, how did you get that? Subtracting, right? 8 minus 1 is 7. What is the size? The subtracting? 16 minus 7 again. 7 again, yeah? Every single class must have the same size, right? So first, we have to get the size. And based on how many classes. So let me go up. It's before to get the classes. Yep, here it is. To find the class width. To take the class width, we need the desired class number of classes. How many was? 6. It was 6. Yeah, here it is. 1, 2, 3, 4, 5, and 6. Yeah. So the denominator must be 6. Additionally, we need the largest value and the smallest value. Please look at the 60 data. Which one is the biggest? The biggest distance. I think there's a 47. Which one is the smallest? 1, yeah. So we take the subtraction. 47 minus 1. Let me take the subtracting. 46 divided by 5, please. Yeah. Do you bring your calculator? If not, please use your smartphone. Yeah. The difference, 46 divided by 5, please. Anybody? 9.2? No, I don't think so. Oh, wait. Anybody else?
46 divided by 6.
Huh?
Divided by 6.
Yes, yes.
7.67.
7.6666, 7.67. Always we have to do round up 8. That will be the class width. Just a second. Somebody said the size was a 7, right? Let me go back to the difference between 8 and 1, 7. 7, 7. Then what is the 8? 1, 2, 3, 4, 5, 6, 7, 8. 8, right? And the next one, 9, 10, 11, 12, 13, 14, 15, 16. 8. And the next one, 17, 18, 19, 20. 1, 2, 3, 4. You understand, right? Yeah, even though we take the difference between the two limits, that will be 7. But please understand what is the 8. It's width, 8, right? Yeah. And what? Always round up. So let me give you another example. If we have the K, yeah, K is a symbol for the width, it's a 7.12. How much will be? 8. Round up, 8 again. Always round up. Always round up 8. Right? Yeah. So now, let me see. Yeah, here is the 8, 8, 8. The next one will be 25. Okay, let me count. 25, 6, 7, 8, 9, 30, 1 and 2, up to 32. And 33, 33, 4, 5, 6, 7, 8, 9, 10, 40. And 41 to 1 to 8, 48. Am I right? It's okay, it's okay. Am I right? Yes. Right? Just a second. The other way, 8, adding 8, adding 8, 8, 8, 8. Oh yeah, that is another way. That is another way to get the classes limits. Good, right? Yeah. Okay, so that is the class limit. Yeah. Again, because we had numerator variable. So we have to classify using the class limits, right? But before classifying, we need the K, the class size, the class limit. Maximum minus the minimum divided by desired the number of classes. Right? Okay, the second column is the class boundaries. The next one is the class boundaries. Let me see. On the top, let me put the class limits. 1 to 8, 9 to 16, 17 to 24, and the next one from 25. How? Let me take the blue highlighted. Yep, it's 1 to 8. 9 to 16, 17 to 24, and from 25. That was the class limits. Now the boundary. The boundaries must be a little bit wider. From here to here. From here to here. From here to here. You understand what I'm saying, right? So the very first class boundaries must be 0.5 to 8.5. And the second one, from 8.5 to 16.5. 16.5 to 24.5. There is no gap. There is no gap. It's between the classes. That is the class boundaries. And let me keep going. It's a 24.5 to 32.5 and 32.5 to 40.5 and 40.5 to 48 is a 0.5. Does it make sense, right? And do you understand what's the difference between the limits and the boundaries? Who was the minimum? One is here, right? It's inside of here. Who was the maximum? 47. 47 was here and here, right? Because when we got 8, the class width, we took round up, right? So always we have enough space. It's covered. It's all numbers from the minimum to the maximum because we round up to get 8. Yeah. So the very first one is the class limits, and second one, no gap, class boundary. And now counting. You know what is the tally? You know the tally is the counting tool. Let me try. Okay. Let me see. 13, 13, 13, second one. 47, the last one. 10, second one. 3, first one. 6, oh, 16. 16. Where must we go? 16. 16 here. Inside is less than 60.5. So the 16 is must be going to the second class. Does it make sense, right? 16, the second one. 20 here. Oh, now 17. Now 17. Where? 17 and bigger than 60.5. So the case 17 must go to third one. Good, right? Yeah. So we can count. It's one by one, right? Oh my God, it's the 60s. Let me give you the frequencies. 14. Yeah, the next column is the frequencies. Yeah, already I counted. 14, 21, 11, 6, 4, and 4. When you count one by one by tally, then the first one must be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 4 more. 21, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 20, and 1. 3, 4, 5, 1, 2, 3, 4, 5, and 1. 1, 2, 3, 4, 5, and 1. 1, 2, 3, 4, 2, 3, 4. You know the tally is a counting tool. That is not the frequency. The next column, the numbers. How many cases? 14, 21. There are the frequencies, right? It's a tally is a counting tool. Yeah. Professor Good? Any questions? And the next one is a midpoint. Okay, let me go back to the lines here. Yep, here it is. The midpoint. As a midpoint is between 8 and 9. Simply, we just take the average. why don't you take the sum 1 and 8? Please, addition 1 and 8. 9 divided by 2. How much will it be? 4.5. Yes. The class limit is 4.5. Why don't you take the sum of the boundaries, not the limits? Boundaries, 0.5 and 8. How much will be the sum? 9 again. Divided by 2, 4.5 again. So either way, take the average between two limits or another average between the boundaries. That will be same midpoint, right? Can you take the sum again? 9 and 16, please. And divide by 2 will be 12.5. 12 is a 0.5. Again, when I take the sum with the 8.5 and 16.5, the sum will be 25 again. Divide by 2, 12.5. Keep going, keep going. Take the averages.
We just add 8 to
Yes. Who said that? Oh, so smart. Can you take the difference? 8. How much do you expect the next one? 20.8. 28.8. Thank you. What was the 8? Width. The class width, right? Yeah. So simply we just add 8. Okay, let me visualize for you. Add 8. Add 8. Yeah, does it make sense, right? Yeah, add 8. Yeah. Even like this, add 8. And this one is 8. Yeah, that is the width. That is the size. Yes. Yes, thank you. So that is the class limit. I'm sorry, the class midpoint in the middle. Take the average or any, yeah, there are so many ways to get the correct the midpoints. And the last column, it is the relative frequency. It is the percentages, right? Please take the sum, please. Please take the sum up. How many? Did you sum up? How did you know that?
It's
He said that, yes. Yes. At the beginning. Can you see that? 60? Right? Anybody who sum up? Did you get 60?
Yes.
Thank you. The total will be 60. So when you complete the frequency table, you can check by yourself many ways, right? It's a counting like this, sum up, it must be same as 60, right? And this way is 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, yeah. This way or this way, yeah, you can complete the frequency table. And the last one, what did I say? Percentages from the frequency. How? 14 divided by 60. So the very first one will be 14 as a divided by 60. How much? Please.
23.
Huh?
23.3.
23.33%. Oh, thank you. It's a 23.33%. And the next one will be 21 out of 60. 11 out of 60. Oh, I knew it. 6 out of 60 must be 10%. Yeah. And 4 out of 60. And 4 out of 60. You can do by yourself. Yeah, please complete. Yeah. The frequency. Ah, how much do you expect when I take the sum? The sum of the relative frequencies. It must be 100%. but you might have 99% or 101%. It's because of the rounding problem. It doesn't matter, but it must be 100%. Yes. Yeah, I complete the frequency table. It is good, right? Just a second. What we are doing? What we are doing? What was the title? Organizing the data, right? Yeah, we are organizing the data. So now, please compare 60 data and the frequency table. Anybody who like this one? 60 numbers? No. You like this? Yeah, yeah. Already we summarized. Where is the most? Between 9 to 16 miles. What was the variable? Commuting distance. Where is the least? It's longer than 33 miles. Least. And many people, it's most of people in 16 miles commuting. Yeah, it makes sense, right? Yeah. So it is much easier because already we organized, summarized the 60 data. Yeah, it is much better than this. It's good, right? Any question for the frequency table? Okay, the next one is a histogram. Have you ever heard the histogram? I think so, because the histogram is one of the most common picturing in statistics, right? Yeah. So let me get bigger. Yeah, histogram. See, on the vertical axis, I will put the frequencies. Where was the frequency? Frequency is here. Depends on the boundaries. See, actually the histogram was from the X and Y. It's X and Y picture. Did you take a college algebra? It's X and Y. Yeah, it's the same thing. Right? So the very first class, the class boundary, which was 0.5 and 8.5. See, you don't have to state the very first one is a 0.5 to 8.5. No. Simply just plug is a 0.5 here, 8.5 here. What will be the next? 16.5 here, 24.5 here, 32.5 here, 40.5, 48.5. Because the boundaries didn't have any gap, right? So simply we just made the scale like as the X and Y, right? So simply just plug 0.5, 8.5, 16.5. Then between these two, it will be the first class. Between these two boundaries, second class. And the next one and next one. And we plug the bars depends on the frequency. How many was in the first class boundary? How many was? Huh? 14. Thank you. 14. 14. 13, 14. How many was in the second column and the second class? Second class boundaries. Huh? 21. 19, 20, 21. Next. Oh, there is 11. Thank you. 11. And I can see 6 and 4 and 4. Histogram. Histogram. Where is the most? Between 8.5 and 16.5. Where is the least? Here. Okay. Who is this? Histogram. Histogram. Let me see. Yeah, nobody likes this. Nobody likes the very first one. And now, please comparing frequency table and histogram. What do you like? Histogram? You like histogram? I like histogram. You like? You like? Oh no, I like frequency table. Anybody? Frequency table? Oh come on. Nobody likes frequency table?
It's a lot of numbers.
Oh, it's lots of numbers. You hate numbers.
No, numbers are cool, but it's kind of hard to see what you're looking at.
Let me ask you. It's fine, it's fine. Why do you like histogram then?
It's more organized, like you can easily see what you're looking for.
Easier. What does it mean easier? Simpler. It is a simpler. I don't care where is the midpoint or oh my god, yeah, relative frequencies. No, I don't care. I just want to know where is the most, where is the least. That's enough. Then absolutely you like the history, right? But someone, not you, but someone need more information, right? Yeah, why not? There's more information. Yeah, I understand you hate it. Yeah, but yeah. You know why it is easier and simpler? Because we lost many information. Looks simpler, looks easier, right? But sometimes if I need more information, why not? The frequency table is much better. Much more information. And sometimes too much, right? Yeah. So it's up to you. It's up to you. If you want to present more, yeah, frequency table. Yeah, briefly. Yeah, here is the most, here is the least. Yeah, I think the histogram is will be enough. I think. Okay. So we made the histogram with the frequencies. Any question? On the next page, yeah, another histogram. And now we have to plug the relative frequencies. It's not only, yeah, most of the time we plug the frequency, but now here, the relative frequencies. So here's a 10%, 20%, 30%, 40%. But still, the horizontal axis, they must be the class boundaries. So it must be 0.5 again, 8.5, 16.5, 24.5, 32.5, 40.5, and the last one was 48.5. How much was the percentages for the first one? 23.33 is about 0.23, 0.23, 0.2123. Anybody who got the second one? I got it. The second one from 21 over 60, it was 0.35. The second one is a 0.35. 1, 2, 3, 4, 5. 35. And the third one will be 0.18. 0.18. Next one will be, it was the 6 out of 60, 10%, 0.10. And the last two, 4 out of 60, 0.07, 0.07, 0.0987, and 7. It is another histogram. It's another histogram with the relative frequencies, the percentages, right? Yeah. Let me see. Please compare them. It was histogram with the frequencies. It was another histogram with the relative frequencies. What can you see? Exactly same. Why? Why are they exactly same?
It's the same data.
From the same data. How did you get the relative frequencies? 14 divided by 60. 19, 21 divided by 60. Divided by 60. Same thing. It's the same thing. Why not? Right? Yeah. So with the relative frequencies, we don't have to make both. Either one. In common, with the frequency, it's more common. Right? When we make the frequency table, with the frequency, not the relative frequency is more common. But it doesn't matter. With the relative frequencies, we are going to have an exactly same histogram, right? So you don't have to make both, but take either one, yeah, in common the frequency, right? What we are doing? Organizing, picturing, because we need we want to see the shape of the distribution, right? Look at this. Symmetrical? No, it's not symmetrical. See, this one is asymmetrical. So let me make bigger again. The shape of the distribution, it is symmetrical. This one is our case, skewed to the right. This one to the left. Always I confuse to the right, to the left. Always I'm looking for where is the longer tail. This one is the longer tail to the right. This one to the left. Yeah, it's non-symmetrical, skewed. And this one is uniformly distributed. As briefly we describe as rectangle or the uniformly distributed. Right? And this one is a bimodal. You know what is the meaning of the bi? The bi? Two. 1 and 2 peaks. A bimodal, right? So the reason why we organize the data and picturing, because we want to show the shape of the distribution, right? So that is the main reason. So today we discussed the how can we make the frequency table, but today we had the numerical variable. So because of that, we determined the class limits and class the boundaries, and then we made the histogram. Next Wednesday, I want to stop here, and we are going to take the quiz. But next Wednesday, we are going to discuss how can we make the bar graph and the circle graph. Have you ever heard the pie chart? Yeah, circle graph is a pie chart, right? Yeah. So we are going to have this variable is a cos. How do you think? Numerical? Is it numerical variable? No, it is a categorical, right? So Wednesday, we are going to discuss how can we organize the categorical variable, right? Yeah. So that will be the topic on Wednesday. And yeah, why don't you prepare the clean paper? Yeah, for the quiz number 1. Yeah, here's the quiz number 1. Yeah, please name on the top. And I give you the 20 cases. And why don't you make the frequency table and histogram? It is the quiz number 1. Yeah, it's a make the frequency table and histogram. Look at this. Before fill up the frequency table, then we have to get the class width with the 5 desired as number of classes. So what I mean, when you take the k into the denominator, you have to put the 5. Yeah, the number of the desired is a number of the classes, right? And additionally, you have to take the largest data and the smallest data. See, it is not an exam, it is a quiz. So you can look at your note, my note, but even you cannot understand, you can ask your friend. Your friend don't answer, even you can ask me, right? Yeah, it is the practice. It is another practice, yeah, in class. And I will post homework number 1 today, and there is a more practice, yeah, more questions. It's regarding the frequency table and histogram. And the homework number 1 will be due Wednesday midnight. Okay, yeah. So please take the largest value and the smallest value. Anybody who take the largest one, the maximum? Please tell me. 13? Smallest one? 1? Okay, thank you. So it must be 13 minus 1. Oh, 12 divided by 5. 12 divided by 5. How much? 2.4. 2.4. Then how much will be the K? Always round up. 3. Thank you. Always. Oops. Round up. So what? 1, 2, just a second. 1, 2, 3. Next one will be, oh, just a second. 4, 5, and 6. Be careful. We have to count 4, 5, and 6. Next one, 7, 8, 9. 10, 11, 12. How many desires? Number 5 classes. The last one will be 13, 14, 15, up to 15. It makes sense? Yeah, the K, the class width was 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the next column, the class boundary, it was a little bit wider. I plus n minus 0.5. No gaps, right? So the first one will be 0.5 to 3.5. 3.5 to 6.5. Thank you. Yes. And then just count. Okay. Yep. Here's the data. Yeah. Simply count is one by one, and suggest the frequencies. Sum up must be 20. The sum of the frequencies must be 20. You can check by yourself. Yes. Any question, ask me. Even you can ask your friends. Let me count 1, 2, 3. 1, 2. It's only 2?
Yeah.
It's no 3. Just 1 and 2. It's the 2 values. in the first column, right? And how about the 4, 5, 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? 10, thank you. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You know the tally is the counting tool. It is not a frequency, right? I need the 2 and 10. It's absolutely you fill up the tallies, then figure out as to how many cases, how many values. It's between 1 to 3, 4 to 6, right?
Did you miss a slide?
Hmm?
You counted one of the slides, but not one of the other slides underneath the last set.
I think I checked, but this computer is not my friend. Already I checked. Yeah. So 10, the second class, 10. And just keep going. Between 7 to 9. And the last one will be between 10 to 12. And one more for 13. The next 3 classes are 5 to 1. Are they correct? 2, 10, 5 to 1. Then sum up 20. Right? Yeah, thank you. Yeah. And the next column. How many was? 5. I wrote 5, but yeah, 5 here.
We need to make a histogram for this.
Just a second. Yes, make the histogram. Yeah. Finally, make the histogram. Finally, make the histogram with the frequencies. So I have to make the axis here and put the frequencies. It's maximum 10 and 5, 0. And the very first one is a 0.5, 3.5, 6.5, 9.5, 12.5, and the last one will be 15.5. You remember how did you get the midpoint? Take the average. Yeah. 2, 5. Simply add 3, add 3, add 3, right? Yeah.
What was the total data values again?
Say again.
Total data values.
The total frequencies is must be 20. The total 20. So the midpoint must be 2, 5, 8, 11, 12. Am I right? I hope so.
Yeah.
Thank you. And the relative frequencies must be 2 out of 20. Huh?
14.
Oh, yeah, 14. Thank you. Don't trust me. Always I guess. I'm statistician. Estimation, guess. It must be 10 out of, oh, I knew it. It must be 0.50, 0.5. Yeah. And this one is the 5 out of 20. And 2 out, I knew it. It's 10%, 0.1, right? Yeah. Please don't leave blank. You have to complete the relative frequencies. And when you sum up the relative frequencies again, they must be 100%, right? Yeah. And it must be 20. And you can make the histogram, right? With the frequencies, not the relative frequencies, with the frequencies. When you finish, you can turn in and leave. Go home. Have a nice day. And remember, we are going to have homework number 1 related the frequency table and histogram will be due Wednesday midnight. What? Please? Yeah, give me today. Yeah. I will give you back Wednesday. When you are doing the homework, any question, email me. You don't have to wait until next Wednesday, but yeah, it's up to you.